All right, let's jump right into this explainer. Today, we're unpacking a really fascinating source text titled Watering the Earth, God's Miracle. Now, this text presents a very specific, compelling argument about the hidden mechanics of our planet. We're talking about the highly precise ratio of water to land on Earth. You see, the author argues that this ratio isn't just some random geographic fluke, but rather undeniable evidence of incredible precision and, as they put it, intelligence and design. So we're going to break down the data, walk through some pretty wild hypothetical scenarios, and see exactly what would happen if this delicate balance were tipped even just a little bit. Let's get into it. So, our baseline planetary reality is fascinatingly precise. Exactly 1/4 of the Earth's surface is dry land, while a massive 3/4 is covered by water. It's a strict 75 to 25 split. Now, most of the time, we just accept this as a basic fact, right? We don't really think twice about it. But the source text asks us to actually pause and consider this specific ratio. According to the author, this exact distribution is literally the foundational engine for all life on land. The main takeaway here is that this overwhelming abundance of ocean isn't just wasted space. It is functionally necessary to support the 25% of the globe that's actually dry. To kind of zoom in and put that into a relatable perspective, the source text uses the United States as its primary example. The U.S. alone contains 3.75 million square miles of dry land. Just let the sheer scale of that number sink in for a second. And the text points out a very simple, undeniable truth. Every single square mile of that expanse absolutely must be watered and cared for. If it isn't, well, the author notes there'd be zero vegetation, no grass, no trees, no agriculture, nothing. This massive scale of landmass needing continuous, reliable hydration is really our first clue as to why that 75% ocean is so vital to our survival. Because this specific proportion of water and land strictly dictates our global rainfall, we've got to explore a really compelling thought experiment presented in the text. What would actually happen if this ratio shifted? The author argues that the exact amount of rainfall the Earth receives is directly tied to our current setup. So, to test the precision of this reality, let's just imagine turning the dial on that ratio. What if the oceans were a bit smaller, or what if they were larger? By walking through these hypothetical shifts, we start to see just how precarious and perfectly balanced our current planetary ecosystem really is. Okay, imagine if the ocean were only half its present size. The math here is pretty brutal. Global rainfall would plummet to just 1/4 of its current levels, basically turning the entire U.S. into a vast dry desert. But what if we went the other way? If we expanded the oceans by submerging half the land, rainfall would literally quadruple. We'd just be left with a colossal, uninhabitable marshland. The author uses these two extremes to drive home the point that any deviation from the current ratio would result in complete environmental collapse. It's a total game changer. Seeing this incredibly delicate balance, we naturally pivot to a massive logistical challenge. The text asks another fascinating question. Suppose this natural system just stopped working. What if mankind had to step in and water this entire 3.75 million square miles of land ourselves? I mean, we know there's plenty of water sitting right there in the ocean. A pragmatic person might say, well, let's just grab some pumps and water the dry land ourselves. It sounds like a scrappy human solution, right? But the author systematically dismantles this idea, arguing that trying to replace the Earth's natural rainfall system with human engineering is practically impossible. The source text outlines 3 tremendous obstacles to this human-managed irrigation idea, starting with transportation. Just think about the sheer mechanics of this for a second. We would have to physically extract unimaginable volumes of water out of the ocean and somehow spread it evenly across the entire continent. How do you even pump ocean water deep into the Midwest? How do you make sure it scales over mountain ranges? The short answer is, you can't. The infrastructure you'd need to extract, transport, and evenly distribute this life-saving resource across millions of square miles is a monumental task that completely defies human capability. But okay, let's say we miraculously built the world's largest pipeline. We'd immediately hit a second wall, and that is salt. Ocean water is fundamentally incompatible with terrestrial plant life. The text makes it crystal clear. The salt contained within ocean water would act as a devastating poison. If we sprayed raw ocean water over the continent, we wouldn't be watering the plants. We'd literally be salting the Earth. Nature's evaporation cycle magically desalinates the water for us, leaving the salt behind. Without that natural process, human intervention using ocean water becomes completely toxic. And that brings us to the third, absolutely staggering obstacle, the physical weight of the water itself. The text points out that water is actually 800 times the weight of the atmosphere. Now, when you step outside and feel a gentle raindrop, you don't usually think about its mass, right?
But at the scale required to water millions of square miles, we're talking about lifting and moving an astronomical amount of weight. The author presents this as the final insurmountable challenge. How could mankind possibly transport and disperse a substance that is 800 times heavier than the air around us, across an entire continent? The sheer physical force required to lift that mass out of the sea basins and distribute it from the sky is just mind-boggling.
So the author takes all of these insurmountable human hurdles and contrasts them with our perfectly calibrated 75 to 25 reality to make their ultimate point, that this is undeniable evidence of intelligence and design woven into the very fabric of the Earth. By outlining how flawlessly the current system works to automatically water the planet and how mathematically impossible it would be for humans to replicate it, the text presents a really striking argument. It leaves us with a profound final thought to chew on. Knowing the astronomical mathematical precision required to keep this planet green, are we taking the brilliant, life-sustaining mechanics beneath our feet completely for granted?